We're going to finish the year talking about parent and baby functions. What we're going to, and typically you would have had a test on this to where you would have had to have just had all this memorized and burp it all back to me. You're going to need to know the name of the graph. You're going to be able to have to state its equation, state the domain, state the range, state any vertical and or horizontal asymptotes. You're going to have to let me know if there was any maxes or any mins. And you're going to have to state whether the graph is increasing and decreasing and state in behavior. We're going to do this over several videos so you can soak it up and maybe actually really learn it, because your teachers, as you head on in math, will assume that you know these things. So we'll start first with a video of these, and I'll do my best to explain them as we go. What you're used to this being called is a horizontal line. And that's a wonderful thing. We're supposed to know it's a horizontal line, but that is not part of the name of the graph. The kind of function that this is called a constant function. That's its name. The graph, when you say, oh, what kind of line is that? It's going to be a horizontal line, but it is called the constant function. The equation of a constant function is y equals the number. I'm going to say y equals b because when we write ordered pairs, we usually consider x the a coordinate and y the b coordinate. Its domain is simply going to be all real numbers. And of course, you can write it all reals. If you wanted to, you could write it reals. And what you would see in most books would be interval notation, where we're writing it from negative infinity to positive infinity. And lastly, they would want to know its range. And its range is a single value. It's always going to be whatever this number is, 8, 9. It can be below the graph anywhere, but it's a horizontal line. We could talk about its in behavior. Sure, its in behavior is as x approaches positive infinity, y is 2. And as x approaches negative infinity, y is 2. Most people don't speak about this. I mean, we just don't worry too much about it. The next graph that we're going to examine is what you all are used to calling an oblique line. But an oblique line isn't the name of the function. And it's not just an oblique line, and I'm going to bring it over to get it out of the shadows. Sorry about that. It's really dark in here today. This function has two names. We're used to it being called the linear function, but in this special case, it's also called the identity. And why is it called the identity? It's because whatever y is, x is. And so its equation is y equals x. And so we have this oblique line, which just tells me the kind of line it is. The function it always is linear. This is a linear function. But in this special case, since the b is 0, it's also called the identity function. The domain is the reals, or you could say negative infinity to positive infinity. Its range is also the reals, which you could write negative infinity to positive infinity. It's going to always, because see, now we can talk about increasing or decreasing. in this parent form, this one is always increasing. Or what could you have said instead of saying always increasing? You could have said that it was increasing from negative infinity to positive infinity. So you could just list the interval where it's increasing. It's in behavior. As x goes to negative infinity, what's y doing? It's going to negative infinity. So we're going to say this falls without bound. And as x goes to positive infinity, what's y doing? Y is increasing. And so we can say as x goes to positive infinity that this function rises without bound. Now, like I said, you could just say this goes to negative, y goes to negative infinity, or f of x goes to negative infinity. You could say f of x goes to positive infinity, or y goes to positive infinity. So this is the description of what they call the parent function that I was taught was the baby function because it's undressed. Now, yes, we eventually can make it y equals mx plus b, and I used to list that as a separate function, and then it's just going to be linear, not identity. And then this, of course, is mx plus b. This doesn't change, this doesn't change. But this can be, I could have it if I want to talk about the slope, not just this original function. If the slope's negative, it's always decreasing, and then these two change. But when we talk about the parent itself, just the parent function, this is called the identity or the linear function. So you need to understand we're talking about the parent, that is, in days of yore, the baby function. We're not talking about all linear functions, just the very first one that's ever introduced, which is y equals x. It's called the parent. It's called identity and linear. And it is always increasing. And as I dress it up, I can make it decreasing. I can change the y-intercept and take away the identity. Now we're going to do one more of the functions in this video, and we're going to do the one called the absolute value function. Now when we do the one called the absolute value function, as we go through it, actually we're going to do two more. Absolute value, you also learned in Algebra 1, and its equation of this function is y, or f of x, equals absolute x. As we go along, the domain for this one is the reals, or you could write it like this, or you could say negative infinity to positive infinity. The range is y is greater than or equal to 0. You could say f of x is greater than or equal to 0. You could get really fancy and say y such that y is greater than or equal to 0 and put it in set notation. You know, when you get to college, they do a lot with this set notation, and you really find out that the basis of math, of algebra and everything is indeed sets. And so I don't care how you do it. Most people just tell me y is greater than or equal to 0. In this case, this one adds in the fact we now have a minimum point, and the minimum point is at 0, 0. The min is 0. It occurs at 0. The min is 0. It occurs at 0. And when I ask, when is this function decreasing? It's decreasing when x is less than 0. When is this function increasing? when x is greater than 0. And then they asked me about the end behavior. No matter whether x goes to negative infinity or x goes to positive infinity, what do we see? It's always rising, or y is always increasing. So no matter which infinity x approaches, what do we say? We're going to say the function rises without bound. Now, I'm going to end with the next function, which is where most classes actually end in Algebra 2, basically just doing simple versions of the parabola. But what we learned this year is that this particular function has a lot of names. It is called the quadratic function. We learned that it was called the parabola. And I taught you that it was called the square function. All of these names are important to know. It's quadratic because its degree is 2. It's a parabola because it came from a conic section, and that's the name it was given, and we talked about it. It's the square function because that's how the function's defined. Its equation is y, or f of x, is equal to x squared. Very simple, the square function. Again, very basic. I'm not going to say x minus h quantity squared plus k. That's going to be the dressed up function. But when we talk about parent functions or the baby form, this is simply the basic form when you're going to look like this. The domain, of course, is the reals, which you could write reals, you could write reals. You could tell me negative infinity to positive infinity. I don't care. When I say what's the range, it's going to match. And we can say y is greater than or equal to 0. By the way, you could have written it in interval notation like this. I ask what is the min, and the min is 0, 0. I ask where am I decreasing? I'm decreasing when x is less than 0. Or I mean, honestly, you could have said I'm decreasing and written it in interval notation. Where am I increasing when x is greater than 0? Again, you could write it in interval notation. What's my end behavior? As x goes to negative infinity and x goes to positive infinity, I see that y is increasing without bound. It's heading to positive infinity. Remember, without bound indicates you're heading to a form of infinity. So x is approaching, as x approaches positive or negative infinity, this baby rises without bound. Now I'm finishing the first video and what we're doing today with this. And what I want you to realize is that these two functions' answers, other than their equation and name, exactly are the same. Not because the graphs are the same, but because they have a similar shape. This one is made out of linears or lines, where this one moved us into curves. So this is where you finish usually Algebra 1, although most of us in honors go ahead and do the square root. But this is technically how we finish Algebra 1, and this is where we start Algebra 2, and we do in Algebra 2, we just go nuts with this function. So endeth what you need for today.